Hi, it's Rai, and in this video I will try to explain or compare the differences and the similarities of my Arduino board and the original Arduino. So I will be tackling the actual microcontroller chip, the actual included USB controller, the number of terminals and pin configurations, and the other components included in the board. I will also try to discuss its layouts, designs, the quality of soldering, the memory size differences, and its clock speed. Please bear with me as I try to discuss each one. The first thing that we need to compare is their microcontrollers. With just a glance, you can notice the difference in their sizes. This is because of its packaging and part number. The original Arduino has a DIP packaging and the part number ATmega328PU. My Arduino, on the other hand, has a QFP packaging and a part number Mega328P. The microcontroller is the brains of your computer. It is what executes the instructions in your program. The original is a black rectangular chip with 28 pins. What I have is a black square chip with 32 pins. A USB controller is a signal translator. It converts signals in the USB level to a level that an Arduino Uno board understands. The original has a USB interface chip of ATmega16U2 and a quad flat package with 32 pins. What I have has a USB controller of CH340G and a dual inline package with 28 pins. Both Arduino boards have 14 digital input-output pins, 6 analog input pins, and the same set of power input pins. The difference between a digital pin and an analog pin is that an analog pin is one that can take on any number of values, unlike a digital pin which has only two values, high and low. All of the pins related to power are located in the power and ground pins. You can use these pins to run power from your Arduino to the breadboard circuit. Let us now discuss the other components that can be found in the board. The big voltage regulator requires an input voltage of 5 to 12 volts. It takes the voltage entering from the DC barrel jack and converts it to 5 volts. It plays an important role because if the voltage rises above 12 volts, the regulator will break. The small regulator converts 5 volts to 3.3 volts. We must be careful in handling these components because they can get very hot. Let us now move on with the capacitors. Bigger capacitors act like backup power supplies for the PCB, while the small capacitors are used for filtering out noise. Inspecting the object, a value of 16 is embedded on it. For both Arduinos, it means that the crystal oscillator ticks 16 million times a second. On each tick, the microcontroller performs one operation. A set of resistors can also be found in the board. There are 20K pull-up resistors built into the Atmega chip that can be accessed from software. The value of this pull-up depends on the microcontroller being used. Diodes and transistors can also be found, each playing a vital role in the flow of electricity throughout the board. Let us now proceed to the layout of the printed circuit board. The first thing that we can notice is that the pins of each Arduino are located in the same places. Both of their reset buttons can be located in the upper left of the board. Below it is the USB port, and the black barrel jack is for the input voltage. Their capacitors are located in the same places together with the in-circuit serial programmer or the ICSP. Despite having the same clock speed, the placement of their crystal oscillators are different. Since both Arduinos have different packaging for their microcontrollers and USB controllers, the placement of these items are also disarranged. What you are seeing is for the microcontrollers, and this is for the USB controllers. The on LED is the signal that you can see when you successfully connected your Arduino board to the computer. Checking their placements, my board has its on LED together with the resistor arrays, but the original Arduino has its on LED separated from them. Observing the visual appearance of both Arduinos, one can really distinguish which is the original and which is an imitation of the other. The board color of the original is teal, while what I have is more on the darker bluish side. By thorough inspection of my board, I have noticed that the printed circuit connections at the back is not as prominent and clear as what the original one does have. The components on the board are soldered well and intact, but I believe that it is not as good as the original one. Despite the flaws of my Arduino, I believe that it can perform all the necessary functions that I need for it to work. Because after digging information and a little bit of research, I have discovered that my Arduino can also compete with the original one because it also has a 32 KB flash memory, 1 KB ROM, and 2 KB SRAM. Both have a value of 5 as their operating voltage and an input voltage of 7 to 12 volts. And in terms of clock speed, both Arduinos have 20 MHz as their maximum. But it is advised that they should not exceed the maximum value, so a 16 MHz crystal oscillator is used. Technically, 16 MHz is the clock speed of each Arduino. My final thoughts after comparing the two is that if you have enough money, you should go for the original version because it can be guaranteed that the quality of their microcontrollers to the printed circuit boards and to the internal connections of the board is guaranteed to be fitting and at the standard level for the job or the function that you would want for the board to be. Your safety and the safety of the other electronic components is much more guaranteed by the original than buying fake ones. But if you don't have enough money and only want a substitute or an alternative for the original one, I would say that the version that I got is the perfect substitution for the original. The price of the original Arduino is $23. It is about 1,200 in Philippine peso. Considering that my Arduino can actually perform like the original one at a cheaper price, I guess I got a pretty good deal. And that's it for this video, guys. I hope you learned something. See you on the next one.